For a long time, depression was described mainly as a chemical imbalance. And while neurotransmitters matter, modern neuroscience shows something more accurate. Depression is largely a circuit disorder. It involves changes in how key brain networks communicate. There are three major regions involved: the prefrontal cortex. This area helps regulate emotions and decision making. In depression, it often becomes less active, meaning emotional control weakens. The amygdala. This region detects threats and emotional relevance. In depression, it can become overactive, amplifying negative interpretations. The hippocampus. This area supports memory and emotional context. In depression, the hippocampus can shrink slightly over time, especially in chronic cases, partly due to stress hormones. These areas form loops. When the system is healthy, the prefrontal cortex keeps emotional signals balanced. But in depression, these loops can become biased toward negative meaning, hopelessness, and withdrawal. So depression isn't only about mood, it's about how your brain processes reality. But what changes these circuits in the first place? To answer that, we need to talk about chemistry. Neurotransmitters. Why serotonin is only part of the story. Neurotransmitters are chemical messengers neurons use to communicate. Three in particular are associated with depression: serotonin, mood stability, emotional regulation; dopamine, motivation, reward, pleasure; norepinephrine, energy, alertness, focus. In depression, these systems can become dysregulated. This explains symptoms like lack of pleasure, dopamine, low energy, norepinephrine, and emotional instability, serotonin. But here's the important point. Depression is not simply low serotonin. If it were, treatment would be simple. Instead, neurotransmitters interact with stress response systems, inflammation, hormones, genetics, and learning. They're part of a larger network, which leads naturally into the next major driver of depression: stress physiology. When you experience stress, your body activates a system called the HPA axis: hypothalamus, pituitary, adrenal glands. This system releases cortisol, the main stress hormone. Cortisol is useful short term. It increases energy availability and focus. But chronic stress keeps cortisol elevated. Over time, this affects the brain. It reduces hippocampal function, disrupts sleep, increases inflammation, interferes with dopamine reward circuits, and makes the brain more sensitive to negative stimuli. This is why chronic stress is one of the strongest predictors of depression. The brain is not designed to stay in emergency mode forever. Depression can emerge as the cause of prolonged overload. And once stress enters the equation, another system becomes important: the immune system. One of the biggest discoveries in recent decades is that depression is often linked to inflammation. When the immune system is activated, it releases inflammatory molecules called cytokines. These cytokines can affect the brain, altering neurotransmitter production and reducing motivation. In fact, when humans are sick with infections, they'll often experience fatigue, loss of appetite, low motivation, withdrawal. These are called sickness behaviors. They help conserve energy for recovery. In chronic inflammation, similar behaviors can become persistent. Depression, in some cases, may be the brain responding to inflammatory signals like it's fighting a long-term illness. This doesn't mean depression is just inflammation, but it shows how deeply connected mood is to body biology. And if inflammation plays a role, then lifestyle factors start making more sense. But before that, we need to talk about the most powerful risk factor of all: genetics and early life experience. Depression has a genetic component, not one depression gene, but many genes that influence stress sensitivity, neurotransmitter systems, and emotional regulation. Genetics can increase vulnerability, but they don't guarantee depression. The environment determines whether vulnerability becomes illness. This is often described as genes load the gun, environment pulls the trigger. Early life stress, trauma, neglect, and chronic instability can shape brain development, especially in emotion circuits. These experiences can alter the HPA axis and epigenetic markers, making a person more reactive to future stress. So depression isn't always caused by one event. Often, it's a system shaped over time, a biological sensitivity meeting life pressure. And when pressure builds, the brain adapts. But sometimes those adaptations become maladaptive, which brings us to an important idea. Depression can be understood as a survival strategy that became stuck. Some neuroscientists describe depression as a kind of shutdown mode. When the brain perceives prolonged threat, loss, or unsolvable stress, it may reduce activity, motivation, and reward seeking to conserve energy. Withdrawal reduces risk. Low motivation prevents wasted effort. Emotional numbness protects against pain. These features can help short-term survival. But when the brain stays in this state too long, life becomes smaller. Energy decreases, joy fades, and the person becomes trapped. Depression is not a choice. It is a state the brain can enter and sometimes cannot easily exit. So how do people exit it? That takes us to treatment and why treatment works. Antidepressants like SSRIs influence serotonin signaling, but their real effects take weeks. That delay tells us something crucial. Depression is not solved by instant chemical changes. It's solved by brain adaptation. Over time, antidepressants can increase neuroplasticity, improve stress regulation, and help circuits regain balance. They don't create happiness. They reduce the biological barriers that prevent recovery. Not everyone responds to medication because depression is not one single disorder. There are many subtypes with different drivers. This is why therapy is often combined with medication, because therapy changes thoughts and behavior and the brain rewires in response, which leads naturally to the next major treatment, psychotherapy. Therapies like CBT, ACT, and interpersonal therapy work because thoughts and behaviors are not separate from brain circuits. Repeated patterns of thinking become neural pathways. Depression reinforces negative loops, therapy interrupts them. It helps people recognize distortions, rebuild routines, and gradually restore meaning. This isn't positive thinking, it's cognitive training. The brain learns through experience, and therapy reshapes experience. But treatment isn't only about the mind, because depression involves the body too. Exercise increases dopamine signaling, reduces inflammation, improves sleep, and boosts neurogenesis in the hippocampus. Sleep stabilizes emotional circuits and regulates cortisol. Social connection activates reward networks and reduces stress signaling. These aren't nice ideas, they are biological interventions. Depression isolates people, but isolation strengthens depression. So recovery often means reversing the cycle, small actions that gradually reactivate life. Even nutrition matters, because the brain depends on amino acids, fatty acids, and gut microbiome signals. This is why depression treatment is often multi-layered: chemistry, circuits, lifestyle, environment, and support. And this brings us to the most important final point. Depression is not simply sadness. It is a state where brain networks responsible for reward, energy, motivation, and meaning become dysregulated. It is shaped by genetics, stress, inflammation, learning, and lived experience. It affects the entire body, not just the mind. Depression can distort perception, making the world feel hopeless and permanent. But depression lies. It convinces you the state you're in is reality, and neuroscience shows it is not. Depression is treatable, recovery is real, and understanding the biology behind it removes the most harmful myth that it is a personal failure. It is not. It is a condition, and like any condition, it can be understood, supported, and treated.